Okay, so we are looking at Unit 4, writing equations of lines given slopes. Our learning targets of today are that we will be able to write an equation of a line given a graph, that we can write the equation of a line given the slope and a y-intercept, and that we can write the equation of a line given a slope in any point. Slope-intercept form requires two things: the slope of the line and the y-intercept of the line. Remember, in y equals mx plus b, that's our slope-intercept form of a line. M is the slope and b is the y-intercept. So m is our slope and b is our y-intercept. Okay, determine the examples where a linear equation can immediately be written from the given information. So here it can't immediately be written because we don't have the y-intercept. Okay, so not for this one. We would still be able to figure it out, but it's not given information. Here we can definitely, we have enough information to figure it out, but not immediately. We would have to do some calculations first. So no, not immediately. This one, they give us M and they give us B. So this one, yes, we could write it immediately, and it would be y equals 2x plus 6. So remember, it's y equals mx plus b. So this would be y equals 2x plus 6. That would be our slope-intercept form of the line. What is different about the other examples? The slope and the y-intercept are not explicitly given. All right. So first of all, let's talk about writing the equation of a line given the graph. So when we are given the graph, we can see the y-intercept and we can see the slope of the line. So let's look at this first example. We can see the y-intercept. So the line goes through the y-axis at b, so b equals 1. And then we can see the slope. First of all, it's negative. And then we look for the rise over run. So we'll choose any 2 points. I'll choose this point and this point. I will make a reference triangle. I'll go down and over. And my rise, so starting at this point, my rise is 1, 2, 3, rise over. My run, starting at this point and then counting, is 1, 2, 3, 4, 5. So my slope is -3/5 and my y-intercept is 1. So that's enough information for me to write the equation of the line in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So this equation would be y equals -3/5 x plus 1. Okay, so that's our slope, -3/5, and that's our y-intercept, 1. Okay, example 2. We have our y-intercept is visible. It's 4, so b equals 4. And then we can calculate our slope. Let's see, here's a point. We'll use that one. And here is another point. So we'll use those 2 points to determine our slope. Yeah, it didn't exactly go through that one, so that's why I went down. So we make our reference triangle going down from here and over from that point. And then we look for our rise over run. This slope is going to be positive because as we read it from left to right, it's increasing. So it's going up. That's a positive slope. So we have a rise of 1, 2, 3, 4, 5, 6, 7, and a run of 1, 2, 3, 4, 7/4. And for most of our history of math so far, up until Algebra 1, we have always told you when you have 7/4, let's go ahead and rewrite that as 1 3/4. And we actually would rewrite that as 1 3/4 if we were graphing it, if it were in an ordered pair for a point. But when we're talking about slope, we actually prefer to leave it as an improper fraction. So we have that rise over run. Okay, so we're going to leave it as an improper fraction. So the equation of this line would be y equals mx. So here's our m. So y equals 7/4 x plus 4. Okay. And then we move over here to our third graph. We have a horizontal line. Sorry, those arrows did not come through, so go ahead and write those arrows on. So we know that in a horizontal line, it's going through the y-axis at 4. All of its y values are going to be 4. Okay. And I know we just learned about equations of horizontal and vertical lines, so that's still something that we're still learning and practicing. But so if it helps, you can make a table of values and you could list those points like -3, 4, -2, 4, -1, 4, 0, 4, 1, 4. You'll see all of the y values are going to be 4. So let's do that. -3, 4 is this point. -2, 4 is this point. -1, 4, 0, 4. Then we have 1, 4, 2, 4, 3, 4, and 4, 4, etc. Okay. And so we see that all of our y values are 4. That's the equation of this line. Okay. The equation is y equals 4. And if you want to think of it as slope-intercept form, well, what is the slope of that? Horizontal line. We've talked about horizontal lines. So, for example, the floor in your house, you want that to have a slope of 0. You want that to be perfectly level. So, this line has a slope of 0, and this line has a y-intercept at 4. Okay, so if we wrote this in slope-intercept form, it would be y equals 0x plus 4. However, this is not a simplified and desirable format. Okay, we don't want to have 0x. 0 times x is going to be 0. It doesn't matter what x is. 0 times anything is 0. So when we simplify this equation, it is just y equals 4. So the equation of that line is y equals 4. Okay, for now, while we're getting used to writing equations of lines, if you write y equals 0x plus 4, I'm not going to mark that wrong, but I do want you to kind of get comfortable with this format as well, because that's the equation of this line. Okay, so this is not simplified. So really, we want to get real comfortable with writing y equals 4. Okay, part 2. I can write an equation of a line given the slope and the y-intercept. Okay, so first of all, let's just remember the y-intercept is also frequently referred to as the b value. Okay, and the slope is frequently it's referred to as our m value. So number one, if our slope is -3/4 and our b is equal to 10, the equation of that line would be y equals -3/4 x plus 10. Number two, m is 10, the y-intercept is 0. We would have y equals 10x plus 0, which is not simplified. So we would simply write y equals 10x. Okay, number 3, m is 0 and b is 9. This would be y equals 0x plus 9. 0x is just 0, because x times it doesn't matter what x is, anything times 0 is 0. So this will be 0 plus 9, which will simplify to y equals 9. Okay, let's go ahead and turn the page. The next objective is, let me adjust the camera. I can write an equation of a line given the slope and a point. When given the slope and a point, we have a little bit more work to do. We work with point slope form. Okay, y minus y sub 1 equals m times the quantity x minus x sub 1. So these 2 points, okay, sorry, my highlighters, okay, x sub 1 and y sub 1, those are the 2 coordinates of those are the coordinates of a given point. Okay, so for example, find the equation of the line with a slope of -3/5 that goes through the point 15 and -2. So this is our x sub 1. This is our y sub 1. So this is point slope form. This is the second form of a line that we're working with. We have already learned slope intercept form. Point slope form is new to us. So all we're doing is similar to y equals mx plus b. But instead of our point being the y-intercept and knowing what our y-intercept is, this form of a line is useful whenever we have a different point that's not the y-intercept. All right, so we would just plug in those points into our point slope form. So here's point slope form. Y minus y sub 1 equals m times the quantity x minus x sub 1. So that's point slope form. And then we substitute in the values that we do know, leaving our x and our y the same way that when we write our answers in slope-intercept form, we leave our x and our y. Okay, so this stays in. That's part of the form of the line, because remember, these, the x and the y, are all of the different points that lie along any given line. So we leave the x and the y in, obviously, except whenever they are 0. Okay, so when we do this problem, m is negative 3/5, x sub 1 is 15, y sub 1 is negative 2. Okay, so y minus y sub 1 is negative 2, so minus negative 2 equals m is negative 3/5, so negative 3/5 times the quantity x minus x sub 1 is positive 15, so x minus 15. Okay, so that's a little bit complex. We need to do some simplifying. So y minus negative 2 is the same as y plus 2. Bring down the equals. And then we need to distribute. And when we distribute, we need to remember to distribute the negative sign with the 3/5. So if you are somebody who forgets to distribute the negative, you might like to circle it and draw those arrows. Negative 3/5 times x is negative 3/5 x. Okay, and then negative 3/5 times negative 15. And negative times a negative is a positive, so we write a plus. And 3/5 times 15 is, we do our cross canceling. Okay, those are both divisible by 5. That's 9. So y plus 2 equals negative 3/5 x plus 9. Okay, so this is still not quite simplified. Okay, so here it is. I'm just copying it over because I ran out of room here. Y plus 2 equals negative 3/5 x plus 9. So this is almost in slope-intercept form. The y is almost isolated. We just have that plus 2 there, and we want the y to be isolated. So we just need to subtract 2 from each side. Then we get y equals 2 minus 2 is 0. So we get y equals negative 3/5 x plus 7. And then we have our equation in slope-intercept form. Okay. Write the equation for the line with the given information. Okay. All right, then we can actually leave these in point slope form. I had you switch it. This actually, there it is in point slope form as well. Okay, so write the equation for the line with the given information. Let's go ahead and get these into our slope-intercept form too. We can have them in point slope form. We'll get comfortable with that, and then we'll also get comfortable with simplifying those. So we're just getting stronger with manipulating our variables. Okay, number 1, our slope is 4. Okay, and it goes through the point negative 2, 1. So let's go ahead and write our point slope form of a line. Y minus y sub 1 equals m times the quantity x minus x sub 1. And then we substitute in our values. Remember, this is x sub 1, this is y sub 1. So we will have y minus 1 equals, m was 4, so 4 times the quantity x minus negative 2. All right. We'll simplify that. Minus negative 2, we'll just make that into a plus 2. Okay, that's our equation in point slope form. Okay, so that is it's an acceptable equation. I want us to be comfortable with going from point slope form to slope-intercept form. And eventually we'll learn to go the opposite way as well. But let's go ahead and distribute this to simplify. So let's leave the y minus 1 for now. Let's distribute this 4. So 4 times x is 4x. 4 times 2 is 8, so plus 8. And then to get the y by itself, we need to add 1 to each side. And this gives us y equals 4x plus 9. And that's in slope-intercept form. Okay, number 2, m equals 7/3. Let's see if I can zoom in. Yeah. Okay, so m equals 7/3 and goes through the point -6/12. Okay, just checking our focus here. It seems a little blurry. Okay, so m is 7/3 and it goes through the point -6/12. So here's our point slope form. Y minus y sub 1 equals m times the quantity x minus x sub 1. And our y sub 1 is 12. So we will have y minus 12 equals m is 7/3. So then times the quantity x minus, and x sub 1 is -6. So x minus -6. And then we can go ahead and simplify. Minus -6 is the same as plus 6. And we can distribute. So we have y minus 12 equals 7/3 x plus 42/3. Okay. And then 42/3. 42/3, what is that? 3, 12, it's 14. Okay, so that's 14. And I should have known that in my head, but that's okay. Y minus 12 equals 7/3 x plus 14. Then we add 12 to each side, and we get y. I'm out of space here, so let's just write it here. Y equals 7/3 x plus 26. And again, normally, if we weren't looking at the slope of a line, we would change that to 2 1/3, but we're going to leave it as rise over run. Okay. All right, let's pause for questions. Okay, next we have m equals 1/5, and the line goes through the point -5, 0. So remember, this is our given point, x sub 1, y sub 1. So y minus 0 equals m, which is 1/5, times the quantity x minus -5. We can write minus -5, or we can write plus 5. So then we distribute here. 1/5 times x is 1/5 x, and 1/5 times 5. Remember, of means multiply, so 1/5 of 5 is 1. Y minus 0 is just y. Okay, so we have y equals 1/5 x plus 1. Okay, number 4. The slope is undefined and it goes through the point 5,4. So we know that a vertical line has an undefined slope. Okay, so we know, if you can envision this, here's a little visual aid for you. There's your coordinate plane. We want to go through the point 5,4. So you would go right 5 and up 4. So maybe right about there, you would have a vertical line. Okay, we know the vertical line is going through the x-axis at 5. So the equation of that line is x equals 5. And if that's confusing to you, okay, until you kind of get a little bit more familiar with it, it's okay to make a table of values. So if you are not sure if it's an x equals line or a y equals line, have that visual aid here, make that diagram to help you. That is a tool of math, visual aids. And then go ahead and plot points. So we have the given point was 5,4. This point is 5,0. This point is, let's do 5, -4. And you'll notice all of the x values are equal to 5. So the equation of a vertical line, it goes through the x-axis at 5, and all of the x values are 5. And this table of values is just an aid to help you. You don't have to write that, but it is just something to help you if you need something more spelled out. Number 1, write the equation for the line with the given information. M is 0, and it goes through the point 3, 1. So we know when we have an m equals 0, that's going to give us a horizontal line. Horizontal line is going to go through the y-axis, and it's going to go through at 1. So the equation of that line is going to be y equals 1. Okay, if that's too much for you to do in your head, that's okay. Make a diagram. We can always fall back on our visual aid. So here is your coordinate plane. The slope is 0, so we know that's perfectly level. So 0 slope. And then it goes through the point 3, 1. So right 3, up 1. There's your given point. Draw your horizontal line. Notice that all of your y values will be 1. If I would have exactly hit that, let's pretend that's perfect. So here's 0, 1. Let's do -3, 1. And there's 3, 1. So if you made a table of values, -3, 1, 0, 1, and 3, 1. And you notice all of your y values equal 1. Okay, so the equation of the line with a slope of 0 that goes through the point 3, 1 will be y equals 1. Okay, number 2, they tell us the slope is 4, so m equals 4. Our y-intercept is 10, so we know the y-intercept is b. B equals 10. We know slope-intercept form, y equals mx plus b, so we can write that equation, y equals 4x plus 10. Okay. Number 3, the slope is 10 and the y-intercept is 0. So m equals 10, b equals 0. Okay, so y equals 10x plus 0 would just be y equals 10x. All right. Number 4, the slope is 3/2 and it goes through the point -4, 6. So here again, we have the slope and we have just any random given point. So here we want to have point, slope form. Okay, so we are given a point and we're given the slope. So we want to use point, slope form to help us to write that equation. So y minus y sub 1 equals m times the quantity x minus x sub 1. So y minus 6 equals 3/2 times the quantity x minus -4. Minus -4 is the same as plus 4. Okay, so that's a good answer, but let's go ahead and just for practice manipulate that into slope-intercept form. So we will have y minus 6 equals, then we're distributing this 3/2. So y minus 6 equals 3/2 x plus 3/2 times 4 would be 12/2, which is 6. All right, and then we add 6 to each side to get y equals 3/2 x plus 12. Okay, y equals 3/2 x plus 12. Okay, number 5, we are given a graph. All right, and when we look at this graph, we can see that our y-intercept is at -2. And our slope is, I'm just going to use this point, rise is 2, run is 1, so our slope is also 2, and it's positive. All right, so the equation of this line is y equals 2x minus 2. Okay, we have a slope of positive 2 with a y-intercept at -2. Y equals 2x minus 2. Number 6, we're given the graph. We see we have a negative slope. Our y-intercept is at +1. And it's a little hard to see. There's a point right here. And this is rise 1, 2, 3, and a run of 2. So our slope is negative, and it's 3/2. So remember that rise over run. So negative, because it's going, as we read it left to right, it's falling, okay? As we read it left to right, that line is falling. So our slope is negative 3/2, rise over run. There's your visual reference triangle, and our y-intercept is 1. So in slope-intercept form, we would say y equals negative 3/2 x plus 1. Okay, and that is writing equations of lines in slope-intercept form, point slope form, in a variety of different situations, given a variety of different inputs, whether that's a graph, given points, descriptions of the line.